Saxon Algebra 1, Lesson 10. In this lesson, we discuss division by zero, exchange of factors in multiplication, and conversions of area. Division is the inverse of multiplication. What this means is that the result of the division, here called C, when multiplied by the divisor B, produces the dividend A. For example, 12 divided by 3 is 4 because 12 is equal to 4 times 3. What if one of the numbers is 0? Is 0 divided by 3 equal to 0? Well, that's the same as saying, is 0 equal to 0 times 3? And of course it is. So 0 divided by 3 is equal to 0. What about 3 divided by 0? Is that 0? If so, it would mean 3 is equal to 0 times 0. But this doesn't make sense. So 3 divided by 0 is undefined. You can't divide by 0. 0 can be in the top of a fraction, but not in the bottom. Here are some examples. 4 minus 2 minus 2 over 13. The top simplifies to 0, so that's 0 over 13. And that is 0. You can have 0 in the top. 8 over 6 minus 2 minus 4 is 8 over 0. But you cannot have 0 in the denominator, so that one's undefined. Negative 3 minus 3 over 5 minus 2. Negative 3 minus 3 is negative 6, so that's negative 6 over 3, which is just negative 2. Negative 5 plus 5 over negative 7 plus 5. That's 0 over negative 2, and you can have 0 in the numerator, so the answer is 0. Negative 8 plus 6 plus 2 over 8 minus 4 minus 4. That gives you 0 over 0. Well, you cannot have 0 in the denominator, so that one's also undefined. Exchange of factors in multiplication. Consider the following product. Negative 4 times 3 times negative 6 times negative 2. If we multiply pairs from left to right, we get negative 12 times negative 6 times negative 2, which is 72 times negative 2, and that's negative 144. So we find the product is negative 144. Suppose the factors decide to change places. If we now evaluate the product, multiplying pairs from left to right, Negative 2 times negative 6 is 12, and then times 3 times negative 4. Twelve times 3 is 36. And 36 times negative 4 is negative 144. So we again get negative 144. So the order in which two or more numbers are multiplied does not matter. This is the commutative property of multiplication. Our next topic is conversions of areas. Unit multipliers can be used to convert areas. For example, how many square inches are in a square foot? A square foot is 1 foot squared, or 1 foot times foot. Since 1 foot is 12 inches, we will use the unit multiplier 12 inches over 1 foot twice. Here we have it. The feet cancel in the top and the bottom. That leaves us 12 inches times 12 inches, which is 144 square inches. To understand this, let's look at a square foot. That's a square 1 foot by 1 foot. We can place square inches in that square foot to fill it up. There's 12 square inches. Here comes another 12. And another. Isn't this exciting? It's going to take 144 of these square inches to fill up the square foot, because we have 12 rows of 12 square inches per row. There we have it. There are 144 square inches in a square foot. Example 2. Convert 44 square inches to square centimeters. One inch is 2.54 centimeters. So we will use the unit multiplier 2.54 centimeters over 1 inch twice. 44 square inches is 44 inches times inches. And if we use the unit multiplier, the inches cancel each time we multiply by the unit multiplier. So we're left with 44 times 2.54 times 2.54 square centimeters. We're not going to multiply this out. The point is that you have to use the unit multiplier twice in order to cancel the square inches. Example 3. Convert 125 square centimeters to square feet. This time we will use 4 unit multipliers. First we'll convert to square inches, then from there we will convert to square feet. So 125 square centimeters is 125 centimeters times centimeters. We can multiply that by 1 inch over 2.54 centimeters twice, and that by 1 foot over 12 inches twice, because then the centimeters will cancel, and the inches will cancel, so that the only units left are feet times feet in the numerator. In other words, we have 125 divided by 2.54 times 2.54 times 12 times 12 square feet. Again, we are not going to pull out a calculator and figure this number out. The point is that we have to use the 4-unit multipliers, 2 of them to convert to square inches, and then 2 more to convert that to square feet. This is the end of Lesson 10. Assignment: Problem Set 10 on pages 49 and 50 of your book.